Develop schedule. This is a process of analyzing activity sequences, durations, resource requirements, and schedule constraints to create the project schedule for project execution and control. You can see that we have a very large number of inputs, with quite a few of these actually coming from the other processes within the project schedule management knowledge area. We'll be discussing the tools and techniques and the various outputs over the next several slides. Schedule network analysis is an iterative technique that we'll be using to evaluate the various inputs to this process to actually generate our project schedule. The critical path method is something that you will very likely see on your exam, and something that we will see in the next several slides as well, and actually do a walkthrough of a forward and backward pass and give you an opportunity to go ahead and do a little bit of practice as well. Resource optimization techniques refers to a situation where resources have been over allocated for whatever reason. So I like to use the example of if we have one forklift, but it's supposed to be in two places at the same time. How can we go ahead and deal with this situation? Well, it's going to depend on how much flexibility we have within our schedule. If we have an ability to allow our schedule to slip, then we can go ahead and do resource leveling. This is where we'd actually change the activity start and finish dates, and that would cause the schedule to slip to some extent if the critical path changes. Now, with resource smoothing, it's going to be a little bit of a different situation. The schedule is not able to slip. We have a hard deadline. There's possibly an externally imposed deadline. So in this situation, we want to go ahead and look at where do we have float, specifically free and total float. There are three types of float that you can see within your schedule. Total float is simply calculated by doing the late finish minus early finish formula that we've talked about previously. With this formula, it tells us how much wiggle room do we have within that specific activity before we'd end up delaying the critical path and in turn throwing the project schedule out of whack. With free float, it's a little bit different. Free float allows us to go ahead and delay an activity without even affecting the early start of any successor. I'm going to step back just one slide here real fast and give you an example of free float. So what we see with activity D, we have an early finish of 20 and a late finish of 23. If we use those 3 days of float, it does not delay the early start of the successor activity, activity F. So whether or not we use those 3 days of float, we're still able to meet the early start of the successor activity. But if we look at activity B, we have 1 day of float. The early finish is 14 and the late finish is 15. But if we use that 1 day of float, it interferes with the early start of activity D. So again, with free float, it does not interfere with the early start of any successor activities. So with activity B, we have 1 day of total float. With activity D, we have 3 days of free float. Project float is something that we've discussed a little bit earlier. This is typically occurring because of an externally imposed deadline. Somebody has told us that you have this amount of time to complete all of the project work. Project float could be positive or negative. It's going to be pretty rare for it to be a negative project float, but it is a possibility. This is how you would end up with any type of float along your critical path. Data analysis allows us to go ahead and evaluate different scenarios that could occur. So what if scenarios is one situation. This is where perhaps we just have discussions about what if there's too much inclement weather, what if the suppliers are late with deliveries, what if there's a labor dispute, and so on. We can also use a Monte Carlo analysis, and this will create a probabilistic distribution, something that we will discuss at greater length as part of the risk management knowledge area. With schedule compression, in some situations, we may need to go ahead and compress the schedule. Anytime we talk about compressing the schedule, if we are trying to shorten the project overall, well, we would have to shorten the critical path because the critical path is that longest duration sequence of activities and also the shortest amount of time to complete the project. We don't want to do this unless we really have to because it will have some type of impact on our project. The two techniques we're going to talk about do have various impacts that could occur to our project. With crashing, the primary impact is that we will be spending more money. Could we also possibly be introducing further risk? That is a possibility. However, the primary concern is that we will be incurring a higher cost. For the purpose of the exam, you will not have to calculate crashing costs. That is not a formula that we will be discussing. For fast tracking, what we're going to do is we're going to take these various activities out of the preferred sequence of events. So we are going to leverage those discretionary or soft logic relationships. And we're basically going to say we're going to do these out of order. Instead of painting the ceiling, painting the wall, and then replacing the carpet, maybe we're laying down that brand new white carpet and then painting the ceiling red right afterwards. What we're doing is we're increasing risk. Is there a possibility we may also incur further cost? It's possible, but the primary concern is that we are increasing risk. So with compression, the big takeaway here of crashing is kind of like crashing a party. We're adding resources that we did not originally plan for. This will cost more money. With fast tracking, by moving activities around out of the preferred sequence, now that's a very risky way to do it, so we are increasing risk. With agile release planning, this is where we're looking at just a couple months at a time. This is based upon a product roadmap. Now, again, with Agile, this is iterative or incremental delivery. So we are going to be adding features and adding some aspect of the deliverable as time progresses. So we don't have to plan out everything all at once. It's going to be at a very high level, and we're just going to basically do rolling wave planning as we move forward. Outputs from this process. We have our schedule baseline. It's going to be the accepted and approved version of the schedule. Now, the project schedule, I do want to very clearly differentiate between the project schedule and the project calendar. The project schedule tells you what are the start and finish dates for the activities. We could have a milestone chart, a bar chart, or also known as a Gantt chart, or a project schedule network diagram. With a project calendar, this is going to be the working days and shifts that are available. So think about your organization. If you're only allowed to work Monday to Friday and you have to go ahead and scratch off federal holidays, or perhaps you have other periods of mandatory training requirements, whatever else it may be, then you'd only have certain periods that you'd be able to go ahead and complete scheduled work. Anytime we see that word calendar, I like to think about availability, just like with resource calendars. When are your resources going to be available for project work? We also have our scheduled data. Scheduled data is a companion document to the project schedule, so this could include more information about these activities, their attributes, assumptions, and constraints, and it may also include resources by time period, alternative schedules, and contingencies. Now, with the alternative schedules and contingencies, we will discuss this further as part of the plan risk response process, where we will actually discuss building contingency plans and how we would implement them. Some more outputs from this process could include change requests. Modifications to the project scope or schedule may result in a change to the baseline or other components. And we do have to keep in mind, anytime that we add work, if we modify the scope or if we de-scope from the project, if we remove some aspect of the scope, that will have an impact on the schedule and in turn will have an impact on the budget as well. Any changes to the schedule or any of the baselines will be done through the perform integrated change control process. We will use formalized change control. The project management plan updates, the schedule baseline. So again, the baselines are part of the project management plan. And also, while we're developing the schedule, we may realize that we want to change some aspect of the methodology or the how. How are we doing this? So we may want to submit a change request and modify our schedule management plan. And finally, we have our project documents updates. So the resource requirements, if we're doing some type of resource optimization, possibly leveling, then we would want to go ahead and update when do we need these resources now. Our activity attributes, now that we have start and finish dates. The project calendar, to go ahead and reflect which working days and shifts we'll actually be using. The risk register, if we identify specific areas on the project schedule that are of concern or that pose a great amount of uncertainty. The lessons learned register, because we do want to enable that double loop learning. And finally, the assumptions log, and the assumptions that we're making as we develop the schedule. So we just finished discussing the develop schedule process. To do a quick learning assessment, Describe the importance of the critical path. The critical path is going to determine the total project duration, and any slips along the critical path will delay the project. What are the pros and cons of crashing and fast tracking? So, crashing is expensive and fast tracking is risky. When we're dealing with the compression of the schedule, we need to go ahead and figure out, do we have more money or can we tolerate more risk? And that's going to kind of determine which technique we would use and which would be better for that. What is the difference between resource leveling and resource smoothing? Resource smoothing only allows the activity dates to be modified within the float values that they have. So we're not changing the project duration. We're just making minor adjustments based upon float. But resource leveling will allow the schedule to slip in order to optimize our resources. What is the difference between project calendars and resource calendars? A project calendar is going to tell you what working days and shifts are available, whereas a resource calendar is going to tell you when are your resources going to be available to contribute to the project in some capacity. Explain the difference between free float, total float, and project float. Free float is the amount of time that an activity can be delayed without delaying the early start of any successor activity. Total float is just the amount of time that an activity can be delayed without delaying the entire project. And that one's a little bit easier to calculate. That's a very simple late finish minus early finish. And finally, project float is going to be the difference between the early finish of the project and an externally imposed deadline. What is the benefit of agile release planning? Agile release planning provides a more easily understood project schedule for the customer by defining which features will be available at the end of each iteration.